Everybody, lesson 8 is on percentage purity calculations. So what is percentage purity? It is the actual mass of the substance divided by the mass of a sample turned into percentage, so multiplied by 100. Our first example, we have shells containing calcium carbonate as well as other minerals. So we want to find out how much calcium carbonate there is in a specific shell. So an experiment was done and it is found that a specific shell weighs 5 grams. So the total mass of this shell, I'm going to write it down, this is the total mass, MT. After performing an experiment in a crucible to analyze the composition of the shell, it is found that the mass of the calcium carbonate in the crucible is 3.2 grams. So this is the mass of calcium carbonate. The mass of the crucible is 0.5 grams. So this is the mass of the crucible. How much of the shell is calcium carbonate? Now, it sounds like the mass of the sample is 5 grams and the mass of the calcium carbonate is 3.2 grams. At this point in time, the information about the mass of the crucible is irrelevant. All the calculations were done for you. So the percentage purity, or we could say the percentage calcium carbonate, is 3.2 out of 5%, which is 64%. Right. Number 2. Limestone is mostly calcium carbonate as well. So Jake wants to know how much calcium carbonate there is in a 3.5 gram sample of limestone. He adds concentrated hydrochloric acid to the sample because the acid reacts with the carbonate and removes the calcium carbonate from the solution, and he finds that the mass of calcium chloride produced is 3.6 grams. Calculate the percentage purity of the sample. So it seems like we need a balanced equation here. So calcium carbonate reacts with hydrochloric acid and it makes calcium chloride and carbon dioxide and water. We need to balance this equation. It seems like we need to put a 2 in front of the hydrogen chloride. So we've got 1 calcium on each side, 1 carbon on each side, 3 oxygens on each side, 2 hydrogens on each side, 2 chlorines on each side. So the mole ratio is 1 mole to 2 moles to 1 mole to 1 mole to 1 mole. Now the things of interest is this 3.5 grams is the total mass of the sample. And he finds that there is 3.6 grams of calcium chloride produced. So we need to know what mass of calcium carbonate is there in this piece of limestone? Now, if I can take you back to grade 10, which is not easy, we need to work with the mole ratio. So 1 mole calcium gives us 1 mole calcium chloride. So this mass must be converted into moles. So that stuff must go to moles. So to convert this to moles, I need to change it by dividing the mass by molar mass. So I divide the 3.6 by, and the mass would be 40 plus 2 times 35.5, which is 71. So 3.6 divided by, so 71 plus 40 is 111. 0.032 moles. So that would be the moles of calcium carbonate required to form 3.6 grams of calcium chloride, 0.032 moles. Now I've kept the unrounded answer on my calculator, so my final answer is going to differ slightly from this using 0.032. So the mass of calcium carbonate is the moles times the molar mass of calcium carbonate, so it's 0.032 times, and I think that works out to 100. So it's 3.2 grams of calcium carbonate in the sample. So the percentage calcium carbonate would be 3.2 out of 3.5%, which is 91.43%. Right, I hope you find this useful. The only example in the textbook that is close to this section is on page 208, 209. Right, see you in the next video.